In this video, I'm going to introduce type definitions, so we can use the typedef specifier to create an alias for a type. Now, this is useful for complex types. You can use it for simple types, but they are typically used for complex types. And that's usually to speed up your programming so that you can write a short type name as opposed to writing a long complex type. In the first statement, we have a look at the syntax. Typedef some known type, such as an integer or a double, for example, or some pointer, and then the alias name, so the name for that type. Preferably you want that to be short. In the second statement you can say an example. So again I have the typedef keyword, I do a pointer to an integer and I call that alias for this type int ptr for int pointer. You can actually swap that around as well, so pointer to an integer. You just kind of have to decide on what you want to do. Maybe establish some sort of standard for yourself. So as explained how you read pointers. Again, you have a pointer to an integer or you have a constant pointer to an integer and so on. So you have to sort of decide how you're gonna go with the naming conventions. Type definitions are generally declared in the global scope, so outside the body of functions, outside of main and outside of your other functions, but they can also be inside of function definitions or the bodies of functions as well. And you'll also notice that I start the alias name with an uppercase. I continue with the camel case, but these start in uppercase, similar to what you would do with a struct. Now, of course, this is just an alias, it's not a declaration of a new type. It's not the same as a struct or a class where you go and define a new type. It's simply an alias for some existing type. Okay, this is the first example. I have this typedef in the global scope. It's an unsigned long, and just for demo purposes, I called it distance. And you can see in main, I have distance. Distance is the alias for this type. So instead of writing this long type here, I simply write distance. Again, I'll start this with a capital and then camel case if I have multiple words. And the reason again that we start the alias or the type definition and as well as classes and structs with a capital is that let's say I want to call this distance here. Instead of d, I call the d here just for short, but let's say I wanted this to be distance, then of course you'll have a conflict between that and the type definition. I'll just call it d, so d is the actual variable, and then I initialize that to 500 and I simply print it out. Build and run and that will print out 500. You can also do a type definition in a function. Let's say I have multiple functions, and in some of those functions you have a type definition with the same name, so with the same alias, but the actual type is different. Then that won't matter. You won't have a conflict with that alias because they are contained in different scopes, so they are local to those functions. But generally these are helpers that you declare maybe at the top of a file and you make them available to all of your functions. So again in the global scope. Okay, I have another demo for you. In this case, I have two type definitions, and we are creating aliases for pointers. First, you might think, where does the asterisk or that star character go? Well, as I explained previously, you read pointers from right to left. We want to create an alias for some pointer to an integer, so I have a pointer to an integer, and this alias is ptr int. Again, you can decide on how you want to do the naming. I've decided to write it in this way, because it reads similar to how you read the pointer type, so pointer to an int. In the second statement, I have another type definition, a constant pointer to an integer constant, so constant pointer to a constant integer or an integer constant. Again, you can decide on the name. In main, you can see we actually have an error, but I'll talk about that shortly. We have int demo int, I set that to 55, then I do constant pointer to a constant integer, give the variable some name, and this is going to be set to the address of this demo integer. So as you can see, I'm just demonstrating the fact that you use it as you would use pointers anyway. The main difference is that instead of writing out this long type, you can come up with an alias. Now, of course, this is a very long name, but this is just for demonstration purposes. We have some constant pointer to an integer constant, and then we set that to the address of demo integer right here. And then I go and do the pointer integer, call that ptr, and then I try and set that to the constant pointer, and that is where we'll get the error. And so you have a conflict. I'll just build and run that and you'll see what the error is. Cannot convert from const ptr to ptr int. Conversion loses qualifiers. Again, I talked about pointer qualification in a previous lecture. If we look at it right here, this means we can't change what the pointer is pointing at, or set that pointer to point to something else. And we also cannot change the variable at the memory location where that pointer is pointing. So how can we fix this? Well, what we can do is we can remove that const. So now it's simply a constant pointer to an integer. So the pointer cannot change. We cannot set the pointer to point to a different address, but we can go and dereference the pointer and change the integer value to the actual variable that the pointer points at. Okay, and this should work fine. Build and run that, and you'll see that prints out and we don't get an error. Okay, so personally I don't really use type definitions all that much, but you may see it being used or you may use it for yourself. Some of the types can get really complex, especially once you use templating along with pointers and everything else. Templating is another topic that we'll talk about later on. So again, your types can get really complex, as we've seen already with the qualification of your pointers. So I hope you found this interesting, and I'll see you in the next video.